Hello guys, I hope you are doing good. Welcome to this new video. The purpose of creating this video is to cover all the basics of JavaScript so that you can use this video as a cheat sheet before appearing for the interview. So if you are preparing or you are interviewing currently, you can go through this video and then you can brush up your knowledge or brush up your basics of JavaScript before the actual interviews. So let's get started. The first thing is JavaScript is a programming language that works in the browser. Before the inception of Node.js, JavaScript used to usually work in the browsers. And earlier, what used to happen is because there was a browser war going on, so every browser had different implementation of JavaScript. Now, it was very challenging for the developers to stabilize the functionalities because there were minor differences in JavaScript language implementation in different browser engine. So what they did is they formed a central committee called as ECMAScript or European Computer Manufacturers Association. This standardization is the centralized feature group that governs the JavaScript feature implementation. So through this, what happens is the next features that will be shipped in the JavaScript are standardized so that it works seamlessly in all the browsers. So every year, all the major browsers, their developers, the representative of the browsers come together and they decide on what should be the next feature that should be shipped in the JavaScript. Now, because JavaScript works in the browsers, so once the feature are shipped, that feature has to be implemented in the JavaScript to make it available to the developers. Now, because it was a time consuming task, right? Because once the features will be decided, then it will be implemented in the browser engine and then it will be available. So after the next release of the browser, the implementation will be appearing. To solve that problem, because it was a time consuming process, there is an introduction of a transpiler called Babel or a tracer. Tracer is by Google. Babel was developed by an individual at the initial stage. Later it was acquired by Cloudflare. So Babel and tracer are transpiler. What they do is they convert the new features of the browser that are not compatible in the browser to browser compatible codes. So let's say your current browser does not support the array filter method. So what Babel will do is Babel will create a polyfill of the array filter method so that with the features that are supported in the browser, so that it works seamlessly in the older browsers where this feature is still not implemented. So that's why Babel and tracer comes in the help. Now from there, Babel has come a far along. So if you see, JSS is something that is not natively supported by any JavaScript engine. So what Babel does is Babel converts the JSX to browser compatible code. So remember this, Babel is a transpiler that converts your code that is not supported by the browser to browser compatible code, and it will use the native features that are currently available in the browser. Because Babel creates polyfills for the browsers that don't support the feature, if your target is older browser, the polyfill size keeps on increasing. So the lesser the number of features that natively supported by the browser, the more polyfills the Babel creates. So when someone asks you how does polyfills affects the bundle size, so you should answer that the older the browser, the more the polyfills. So the bundle size depend upon the dark browser that we are targeting, the version. So this is the governing body, ECMAScript. Now the last major release which has shipped lots of feature in JavaScript was in 2015. So it is called as ECMAScript 6 or ES6. So if in the job descriptions, you will see that most of the companies look for the ES6 plus knowledge. So the next feature that will be available through ES6 is called as ES Next, and depending upon the year we are at, so the version name is decided. So in 2015 it was called ES6 and so on. So 2016 ES7, 2017 ES8 and so on, the versioning is defined. So the major release was in ES6, and through this video we will walk all the features that was provided in ES6 and also the basics of the JavaScript. So we'll try to cover. So let's get started. We have covered the intro, what is ECMAScript, what is Babel, how Babel is useful, and then the intro. Then let's move to the second part, which is variable, and then this remaining things. So we'll try to cover all these things. Now there are three ways to define variable in JavaScript. One using var keyword, then other is using let keyword, and then another way is using the const keyword. So whenever you declare a variable using var, it will be available on the scope, function scope, and it will be hoisted on the top. So if you are defining it on the let scope, the let and const are block scope variables. Now what do we mean by block is, let's say this is the block. So the curly braces represents a block, and anything defined inside the curly braces will be block scope. So you cannot access it beyond that. Now let's define a first variable using var keyword. So var a equals to 10. Now if I try to access a outside, you will see that it is available. So the value will be printed. So see, you are getting 10 printed because the var is hosted on the top. Now var, when you declare a variable using var, it is function scope. So it is not block scope. And because it is a function scope and we are currently running in the main function, so it is hosted on the top. So something similar to this happens. Var a equals to undefined, and then here it will become a equals to 10, and that's why if we are printing, it is available. So this is how something similar to this JavaScript engine does when it is running or executing a variable which is declared using var keyword. But if you declare the same using let keyword, it won't be available. So it won't be hoisted and it will throw error because it won't be able to access a. Reference error, a is not defined. So it is limited to this block only. Now if I take this inside and if I print this, you will see that it will be printed. So see, 10 is printed. Similarly, const works in the similar fashion. So if I run this, const will be printed. It is block scope. It is printed in the block. But if I pull it out, it won't be printed. So if I run this again, you will see that it will throw error. So it is throwing error. The difference between let and const is, once you declare a variable using const, you cannot reassign a value to it. So if I do something like this, it will throw error because we are reassigning the value to the variable declared with const. So see, assignment to a constant variable, we are getting this error. Now the variable declared with var keyword is function scope. So you've seen that when I declared it in a block scope, it was hosted on the top and it was accessible outside that. The same thing if I do it in the function, right? So let's say I'm declaring this function, and then if I invoking the function and if I try to access a, it won't be visible. So we cannot access it. I mean, it will throw error that a is not defined. See, a is not defined. So var, when you declare a variable using var keyword, it is function scope. It's not a global scope. So remember that. Now let's say if I console log a over here, so it will print undefined. Now a is declared after we are printing it. So we are printing it before, the declaration happens after. And if I run this ABC, you will see that we are getting undefined printed. So see, undefined is printed. That is because when a execution happens in a function, anything declared with the where keyword is defined on the top first. So here it will be defined something like this while the execution happens, and here the assignment will take place. So because the declaration happens at the top of the function, you get undefined. So this is called hoisting. Now what if I declare this using let keyword? So let does not get hoisted. Similarly, const also does not get hoisted. And if I run this, you'll see that we'll get error. So cannot access A before initialization. And the term used over here is A is in temporal dead zone. That means that A is not accessible before it is initialized. So you'll get an error. So remember this while whenever a hosting related question is asked. Now let's come to function. So functions in JavaScript are heart of its programming. So JavaScript promotes or supports the functional programming. Now functions are the core blocks. So definitely we are going to use lots of functions in JavaScript. Now let's see. So we have covered variable, we have covered hosting. Let's see the function and then the value of this. Now there are 4 ways to define a function in JavaScript, and similarly the value of this, so this, which is a special keyword that is available inside a function, its value is defined or its value is determined the way function is invoked. So remember this, the value of this inside the function is defined on the way the function is invoked. So first thing is you can declare the function like this, simple declaration. Second is you can use a variable and then you can declare the function something similar to this. Third way is you can create an object and inside that you can declare the function. So this, and another way is you can declare anonymous function. So this is an anonymous function, and also it's a immediately invoked function expression. So we declared it, we are invoking it at the end, so it is called as IIFE. So immediately invoked function expression. So these are the 4 ways to declare a function. Now this is function, this is function, and this is a function, but this, so whenever you define a function inside an object, it is referred as method. So please remember this difference whenever you are using the period operator, which is dot operator, to access something. Let's say I'm using period operator to access a.abc. This will refer as method. So abc is method. While if you are invoking this, like invoking a function like this, so this will be called as function. So this is the difference between a function and a method. These are the 4 ways you can declare a function. Now let's try to see the value of this on the function. So the value of this, again, the value of this inside a function is determined by the way the function is invoked. So here, if you see console.log this, now when a function is invoked normally like this, the value of this refers to global object. So in browser it is window, and in Node.js it is global. So see, if I run this, you will see that we'll get that too many logs because it is completely printing the browser object. Now let's add a check over here if this refers to window. So if I run this, you will see that we'll get true. So this is referring to window. Now because this is referring to window, if you declare or if you assign a property over here, let's say PQR, and then if you try to access that, so let's say I'm just accessing A. So if you are accessing A directly, it will check on the window object only. So let's say window.a or directly A, doesn't matter. And if I run this, we'll see PQR is getting printed. See, PQR is getting printed. So because this refers to window object, and if you are assigning any property, obviously you will be able to access it anywhere throughout the application. But when you declare or use strict keyword and then declare this keyword inside that, so if the function is invoked in the strict mode, the value of this is always undefined. So let's comment this, clear this out and run this. So here the value of this will be undefined. See, so when you are creating a function in strict mode, the value of this will be undefined. Now when you are, so this was the normal invocation. Now let's move to the second invocation, which is of the constructor type. So let's say const abc is equal to new abc. So whenever you are using the new keyword to declare a function, the function is said as, it is called as constructor. So you are creating a fresh instance of that function. Now when I invoke this as a constructor, the value of this refers to a new object. So a new object will be created every time it is invoked. So let's say abc2 and then new abc. So if I print this abc equals to abc2, will get false because both are returning new object. And if you see, if I'm printing the value of this over here, you will get an empty object. So see, an empty object for the first instance. Similarly for the second instance, we are again getting empty object. And if I'm doing a parity check, it is showing that both the objects are different. So the value of this is, so both are not matching. That's why we are getting false. So when you are invoking a function as a constructor, the value of this is an empty object. It's the empty object in the strict case also. So it doesn't matter. Only when the function is invoked as normal, so the value changes. Otherwise it remains same. So in the strict mode also, it is returning the empty object. So let's remove this. Let's clear this. Let's move to the third part. So the third part is the method invocation, which is, let's say const a and then abc is equal to function. And here if I console log this, so a.abc. Now when you invoke a function as a method, the value of this refers to its parent object. So here this refers to a keyword. Now if I invoke this, you will see that the value of this is a. So we are getting the same object returned. So whenever a function is invoked as a method, the value of this refers to the parent object. But a catch over here is, if you extract this method and store it in a variable, let's say I have extracted this method, I have stored it in a variable, and now if I invoke this variable, so here the value of this will refer to window, because if you extract the method and store it in a variable, it is treated as a normal function invocation. So if I print this, you will see that it is skipped. And if I, let's say if I add a check that it is window or not, so you will see that you are getting true in return. So see, true is written. Now the final call is also inside this method, let's say if you invoke a function, another function, inner, if I declare this and if I say the value of this here, and if I invoke this like it, so here, because this function is invoked as a normal function, the value of this will obviously refer to window. Now inside the method, if you declare any inner functions or any child functions, and if you invoke that child function as a normal function, the value will be treated as, so the value of this will be treated as window, or it will refer to window. So see, it is referring to window. Now if you want to change this, so what you can do is you can convert the inner to a fat arrow function. Now in the fat arrow function, what happens is fat arrow functions does not have this keyword available inside them, so they don't hold this value. Instead, what they do is they look for the this in the nearest parent. So here, because inner is a fat arrow function, so the value of this will be pulled from the nearest parent, which is ABC. That is why this will refer to the ABC's this, which ultimately refers to the A. So here, if I say this equals to A, so you will see that true is getting printed. See, it is printing true. So whenever you don't want to have this of your own, you can use the fat arrow function, and it will use the value of this of its nearest available parent. So if you have nested fat arrow functions, then also it will come to the nearest parent where the this is available, and then it will access that. Another way is, let's say I say function inner, I invoke this normally. So another way is we can make a temporary call and then pass the value. So inner dot call this. So what call does is it temporarily changes the value of this inside the function. And if you see, so here I am passing this, which is the this of ABC method that refers to the object A, and it will be passed to the inner function. And if I run this, you will see that the this is referring to A only, and we will get true as printed. So see, true is printed. So another way is you can use call apply. So apply, what apply does is, let's say here there is an argument that the function inner is accepting, which is x. So let's say console.log x. Now the only difference between call and apply is the first value remains the context. So whatever context you want to refer to, here the this is passed. In the call, the second value or the going forward, all the parameters will refer to the function arguments. So let's say if I here I pass as Prashant, then the value of x will be Prashant. So it will run Prashant, and then definitely this is equal to A, so it will be true. And if you are using apply, so you have to pass the arguments as an array. Run. So you'll see that it is working fine. No differences. Only you have the way we pass the argument changes. Then there is another way, which is bind. So call and apply was temporarily used, and it can be used for the frequent calls. We are not permanently changing the value of this. But what bind does is bind permanently binds the value. So let's say const c equals to bind this. Now it will permanently bind the value of this to this function. So if I say c hello or c world, in the both the case, irrespective of how many times we are invoking it, the value of this will be bounded on the initial call. So this will always refer to the value of this inside the ABC. Now if I run this, you'll see that hello and world will be printed, but on both the calls it will be true because this is referring to the A. So this is how the value of this is decided inside the functions. Now let's move to the third part, which is closure and curry. So let me clear this. Let me declare a function over here. So let's say function outer, and then inside that I declare a variable, and then I'm returning another function from this. Let's call that inner, and here I'm printing the value of A. And after printing, what I'm doing is I'm incrementing the value of A by 10. So if you see, if I pull out the, so if I once I declare the outer will be returning the inner. This inner function will be stored in this child, and then if I invoke the child, so on the first call you will see that A is printed whose value is 10, but after the printing it, the value increases. And similarly, if I print this multiple time, you will see that the value keeps on increasing. So 10, 20, 30 and 40. Now here we first invoke the outer function. After its invocation, it has returned another function. That return function is stored in the child variable, and then whenever we are invoking the inner or the child, you see that the inner is still it's able to access the parents variable, and it's able to make use of it. So this is what closure is. Closure in simple term is the child functions are able to access the variables or the properties of the parent functions even after the parent's execution has ended. So here outer is invoked, outer's invocation is completed, its execution is completed, and it has returned as the inner function. Still, when you are invoking the inner function, it's able to access the property of the outer and make use of it. So in simple terms, this is what closure is, and this is a very powerful technique, and it can be used to solve different types of problem. So this is what closure is. Another thing is currying. So let's say we declare A as array, because through closure we are able to access the variables of the outer, and here this is inner function, and inner can accept arguments. So let's say inner is able to accept one argument. Now here we check if A dot length equals to 4, then it is returning A dot reduce A comma B, and ultimately A plus B starting with the 0. So basically it is returning the sum of all the values once A has 4 elements in it. Otherwise it is again returning the inner function. So if you see over here, we invoke the outer once outer has returned us the inner. Now to this inner I have passed 1. Then again it has returned us something. So let's say I make it extremely simple, child 1. So child is invoked. Now child is invoked with the value 1. So here 1 is passed. Now let's say A dot push. So we forgot that we have to store it also. A dot push X. Now here we are receiving 1. So child 1 is receiving passed 1, and so inner will be receiving 1 as argument, and then it is doing the logical check. It is checking if array's length is 4. No, it is not. So it is pushing that value in the array, and it is returning the same function. That means child has returned a function to child 1. Now if I take this and then if I pass it over here, let's say like this, and if I change the value of child as child1, so I invoke child1 with the value 2. Now again child2 will do the logical check. So did we reach 4 elements in the array? No. So that's, then it must be returning the inner function again. So to the child2 there is inner function again. Similarly to the child3 we have the inner function again, and again for the fourth call. So child3 is also accepting, and here 4 is passed. Now after this, if I invoke the child4, so let me console log this. So I console log child4 and you will see that we'll get the sum of all the previous counts. So you see we are getting 10 in the output, which is the sum of all these numbers. So here we have stored, so we are continuously returning a function until our desired condition is met. So we received 4 arguments, and after receiving the 4 arguments we have returned the sum of it. Until unless the condition is not met, we are continuously returning the same function. So this is a concept of currying. Currying is we keep on returning function until a desired condition is met. So now here I have simplified it, and by invoking it multiple times and storing in the variable, you can use the shorthand expression, let's say like this. So 3 and then 4, and if I pass child1, so because child1 has been invoked, it's return a function. We are invoking that function immediately with another value. Again it's returning a function, invoking it immediately, and then here also. So if you see, if I run this, it will return the same output. So we are getting 10 in the output. So in simple terms, this is what currying is. Currying is you return function till the desired output is met. Now currying has lots of variations. So in my interview questions playlist, you will see 4 different types of currying problems. So you can go and watch that. I'll add the link in the description, and you can check it on the play card also. So if you are preparing for interviews, you can go and watch all the different currying problems. It is from the easy to the hard range. Now we are done with the closure and currying. Now let's move to the arrays object destructuring and rest and spread operator. Now arrays in JavaScript are also objects. So let's start with objects first, and then we'll move to the arrays eventually, so that it will be easier for you to understand things. So this is a way to declare an object in JavaScript. You use the curly braces to declare the objects. And here, let's say there are 2 things that an object can have. One is property and another is method. So property is something that holds the value, and method is something, so method is a function that can perform operations. Simple as that. Let's say return this dot b plus 10. So every time c is invoked, it will access the b's value and add 10 to it, and it will return this. Now there are many shorthand operators that has been provided after ECMAScript 6 or ES6 that we can use for our advantage, which is if you want to access the properties of the object. Let's say earlier what we used to do is we used to declare a variable, and then we used to say that a dot b. Now a dot b value will be assigned to this variable b. Now to make it easy, what they did is they had provided us an option of destructuring. So destructuring is you can use this curly braces on the objects. So here if you see, I am just referring to the object, and you can access these properties and methods directly over here like this, and this will be declared and can be used as a variable. So we basically pulled out b and c from the a, and this b and c becomes variable, and now you can use it as per your requirement. if necessary, you can change the variable names and you can add the aliases as well to them. So here, if I print the value of aliases, you'll see that aliases is referring to the b, so it's just a proxy. We have updated the name of the b and it is now aliases, so aliases is referring to b. So you can see that when I print the aliases, we are getting 10. Now this is what destructuring is, and this is a shorthand property, and it is widely used throughout the coding. So if you see somewhere that I'm using destructuring a lot while problem solving, so this is what it's basically doing. And then there is spread and rest operator. So let me create a copy of this, another variable. Let's call it d, and then here the value is 20. Now you see we have two objects a and d. It has two properties, one property, one method. It has one property. Now what if we want to merge this value? So values of a and d, we want to combine this and we want to have a single list. So let's say we create a variable named combined. Here I am using curly braces, which is declaring an object, and then you can use these three dots and then a and again three dots and then d. So what it is doing is sorry, it is spreading the value of a, so it will spread all the values of a in the new object, and after that it will spread all the values of d in the new object, and these two will be combined or merged. And if I print the combined, you will see that we get both the values together. So see, we are getting b, c and e. Now in the similar fashion, let's say you just want to access the b from the combined, and the rest you want to store in another variable. So you only want to pull one value from the these three, and the remaining two you want to store in somewhere else. So let's say we can again use the three dots, and this time it will work as rest operator. So rest is basically it will accumulate the values. So it will pull the b out of the combined, so it will pull b, and it will, the rest of them will be stored in this variable called rest. So now if you see, if I print rest, see only c and e is printed, b is pulled out from the combined list. So if you are using it on right hand side, it works as a spread operator. If you are using it on the left hand side, it works as a rest operator. The same thing can be used in functions. So let's say I'm declaring a function, and to this, if I'm using three dot operators, and let's say if I say x, it will accumulate them in the form of array. So not objects, it will accumulate all the arguments in the form of array, and here it is working as rest operator because it is accumulating. So if I print x, you will see that we are getting an array of the arguments. Now let's say you have this function and you have array of value. So let's say const x1, x2 and x3, and here I am printing them console.log x1, x2 and x3. On the other hand, you have an array with the value 1, 2 and 3. Now while invoking the function, if you use the three dot operators and let's say I pass this array, it will work as a spread. So it will pull the individual elements from the array and it will pass them as a individual arguments to the function. Now if I run this, you'll see the value of x1 will be 1, the value of x2 will be 2, and the value of x3 will be 3. So see, it is getting printed separately. So this is how the spread and the rest operator works on the functions. Now in the functions, if you pass an object, then you can use the same method over here. So let's say if I pass a to the function abc, then I can pull b and c from it as I can pull it normally. So b and c will be available as variables. So now let's say I print b over here. I'm pulling both b and c, but I will only print b. Let me remove this, and here I'll just pass a. So a is a object with the two values b and c. So if I run this, you'll see 10 is getting printed. So you can use the spread, rest and the destructuring anywhere where the object is passed. So see, this is how it works. Another thing is, in the functions you can use default values. So let's say x and y, these are the two values that we are expecting in the function. Now we say that x should be the mandatory argument that we should remove, but the y can be optional value, and we can set the value of y as default. So the console.log, if I do x plus y, and here if I pass 20, you will see that it will take x value, but because y is not passed, so it will take the default value of y and it will print 30. So 30 is printed. Now the value of y can be default, or it can take the value of its left hand side arguments. So it can also take the value of x, because x is declared before y, so y can access the value of x. So if you see, if I pass 20 over here, the value of x will be 20, y will take the value of x, so it will be also 20, and ultimately 40 will be printed. So see, 40 is printed. So this is how you declare the default values in the function along with the restructuring, spread and the rest operator. Now to iterate an object, a new loop is introduced. So to access the value of objects, we need to access its keys first, and then using the key we can pull out the values of the object. Now one way is to use this square brackets, and inside that you can access the key like this. So if it is a string key, you have to pass it as a string. If it is a numeric key, you have to pass the number. So I can access like this. Otherwise, I can use the period operator and I can access like this. So both the works to access the value of the object. Now to iterate the object, we have a new loop called for in loop. So in a. Now what for in loop does is it iterates over the keys of the object. So in the a there are two keys b and c, and it will iterate over the key. And let's say if I print this, you will see that we are getting b and c printed. So b and c. Now you can use this key and then you can access the values of object. So a key, it will give 10 and then a function. Now here you have to pass the key in the square brackets, because inside the key is actual value of the key that the object has. And if you use the dot operator, it will treat the key as the key text present in the object. So something similar to this. So if key text is present, then it will return the value, and if it is not present, it will return undefined. So see, undefined is written. That is why always when you are dynamically accessing the keys of an object, use the square bracket as a default. Okay. Now let's move to object. Objects in JavaScript are also, so objects, sorry, arrays in JavaScript are also objects. So 1 and 2. Now these are also objects in JavaScript. And if you want to access the values of array, we have a new shorthand operator available. So you can say first, last of the array, and then the first value and the second value will be pulled from the array and it will be declared as a variable, and then you can use it. So this is a shorthand operator available to access the values of the array. This is how you can access. Sorry, console. My bad. Now if I run this, you see that 1 and 2 will be printed. Now if let's say if you want to skip some value, there are 3 values, and if you want to skip some values, so what you will do is you will add an extra comma. So there it will skip the second value, and the third value will be stored in this variable. So let's say if I print this, if I run this, you will see 1 and 3 will be pulled and then it will be printed. So 1 and 3 is getting printed. Now the spread and the rest operator also works in the objects. So 4 and 5. Now here if I say combined, so again on the objects we used to use curly braces before spreading because it was an object. For the arrays we will be using the spread of square brackets, and here I am spreading both array 1 and array 2, and if I print the combined, you will see the values of both the array will be combined. So if I run this, see it is combined. Similarly, you can use the rest operator to pull the values. So here let's say first and then the remaining rest from the combined. So it will get the first value which is 1 and the remaining in the form of an array. So if I print the rest, you will see that 1 will be printed separately and all the remaining values will be printed as a array elements. So 1 and then 2, 3, 4, 5. So this is how you can use the spread and the rest operator for the arrays also. Now to access the array elements, there is a new loop provided which is for off loop. So here I am using off, and it directly access the values of the array. So let's say console.log value, and it will print. So if I run this, it will print 1, 2 and 3. So each value of the array. Now as I said, arrays are also objects in JavaScript. So if you use the for in loop and you use key as like this, so here the key will refer to the indexes of the array. So you will get 0, 1 and 2 printed. 0, 1 and 2 as a key, and then you can use the array and the square brackets similar to objects to access them on the indexes. So see 1, 2 and 3 are printed. Now because they are similar, you can convert an array to objects using the spread operator. So here I am spreading the array in the object, and what will happen is it will use the indexes of the array as key and the value as value, and it will convert it to the object. So if I console log this, you will see that the array is converted to object. So see, it is converted to object. So you can use an array to spread and convert it to the object. So we have seen the for in loop, the for of loop, the arrays, object destructuring rest, and spread operator. Now let's talk about prototype. So prototype is a way to extend or inherit a function or object in JavaScript. Now let's say you have this array, okay, 1, 2, and 3. Now I want to add a new method to it. So what I want is the new method should be available to all the arrays that are declared in the current scope. So what I'll do is I'll say array. So array is the constructor function, and to this I'll say the prototype, and here let's say I create a method find, and here I'm declaring it as a function. Now inside this, so we have extended the array and we have a method to it. So because see, the prototype is an object and we have added a method to this. Because we have added method, the value of this inside the function will always refer to the array. Okay, so the array on which we are accessing it. Let's say if I say array.find. So first thing is, because we have declared on this array constructor, so this find will be available on the all the arrays. And the second thing is, because this find is a method, so the value of this inside the method will refer to the parent array. Now if I run this, you will see that the value of this will represent this array, and 1, 2, 3 will be printed. So cannot set properties of undefined setting find array dot proto type. Spelling is wrong, my bad. So see, 1, 2, and 3 is printed. So prototype is a way of extending objects in JavaScript. Now this we can use only on objects. So because it works on object, it will only work on the objects and the constructor function, because constructor function returns an object. So here when you declare an array like this, it is declared as a constructor, so it returns a new instance of the array. That is why, because a new instance is written, we are able to use the prototype, and then we are able to attach the find method on this. So this is how in simple terms prototype works. Now when someone says you that you have to create a new method on the array, so by default there are 3 methods or 4 common methods that we are generally aware of, which is filter, map, then reduce. Okay, so let's say you want to extend and you want to add your custom methods to the arrays or objects, so you can use the prototype and you can extend and add that. So let's say I have added find, and let's say I want to find 1. So here we'll see that this dot includes, and here we are accepting a value. So if this includes the value, so return this, and if I console log this, this should return true. So this is a custom method to check if the value 1 is present or not. So see, it is working fine because this refers to array. So array has this includes method by default provided, so we can use it inside this new method that we are declaring. So this is how prototype works. Now let's move to the shorthand properties. So there are 3 shorthand properties: and, or, and then question mark, which is optional. So let's say I have this object, and inside the object we have a property b and abc. Now and operator works on the truthy values. So if the left hand side value is truthy, it will return the right hand side value. For example, if I console log and I say a dot b is there, then print present. Otherwise, if I say a dot c and not present, so you'll see that this will return the present or print the present because a dot b is there. So it's a truthy value available in the object. But because here a dot c is not present, so it will not go beyond that. It should return undefined or false. So let me run this. See, present is printed and then here undefined is printed. So for the falsy values or for the undefined value, it won't go beyond this. So this is the and operator. The or operator works exactly opposite to this. So the or will work when the falsy values are provided. So if I run this, it will print a dot b because a dot b is a truthy value, it's present, so abc will be printed. But in this case, it will say that a dot c is not present. That's why we are giving the optional value which is not present. So the default value for that. See, abc is printed and here not present is printed. Now the third case is optional. So this two question marks. Now these two question marks returns the right hand side value if the a dot b value is null or undefined, either of that. So in this case you will see that a dot b is null, so it will print present, and because a dot c is undefined, then also it will print not present. See, present and not present both are printed. But the and operator only works on the undefined values. So if I run this, see, it is printing null. So it does not include null in the check. It only checks the undefined or the falsy value. So what if I change this to false? Now just to check, right? So if I change this to false and if I run this, you'll see false is printed. So and operator only does the check for undefined. Or operator only does the check for undefined. But and returns the right hand side value when this value is undefined. The or returns the right hand side value when this value is undefined. And the two question marks works for the null as well as the undefined values. So this is the shorthand property. And finally, there is promises and async await. So let's create a test function, and here let's say I give the time, and inside this I am returning new promise, resolve, reject, and here I say set timeout, resolve, sorry, wait. This is the function, and here time will be passed, and here I'll resolve after the time. So this is the test function. This returns a new promise, and that promise will be resolved after the given amount of time. So let's say const promise 1 equals to test and 1000. So this will resolve after 1 second. So here if I say promise 1 dot then, and here we'll get the value, the resolved value, and if I print this, we should get 1000 because we are passing the time while resolving. So if I run this, see 1000 is printed after 1 second. Now if I reject this, then either you can use, so the then function accepts two callbacks. One is for the resolve and one is for the reject. Or you can explicitly use the catch block. So if I run this, you will see that error is printed 1000. So see, this is the console.error. Now, if you don't want to use this, you can explicitly use the catch block. So it will work seamlessly. If I run this, you'll see that 1000 as error is printed. Sorry, console.log. So let's console.error to make sure there is a difference. So see, console.error is printed. Now this is how promises as a normal works using the then and catch, thenable promises. We can convert the same thing to function. So we can declare a async function ABC, and inside this we have to wrap the code in the try catch block, because once a promise is rejected, it will be handled in the catch block. Let's say error and E, and here what we can do is, first let's declare the promise and let's say test 1000, and then you can await the promise to be fulfilled. So because it returns a new promise, right? We are awaiting the promise to be fulfilled, and after that we are printing the value of the await. Sorry, here I have to await because it is returning the new promise. And this is the response. So if let me invoke this. If I run this, see, we get the error as 1000 because we are rejecting over here. If I resolve this, run, so 1000 will be printed in the console log. See, 1000 is printed. Now only difference between the thenable and this async function is, until and unless this part of the code is executed, like the await block, the next block won't be executed. So it will wait till this line of code's execution is finished, and then only it will move to the next block. So here, if you see, if I randomly print console.log hello, it won't be printed. So only after we are getting 1000, it's printing hello. But if you say const promise equals to test 1000 and then promise dot then console.log val, and if I console.log hello over here, let me comment this. Clear this out. So see, I have pulled the promise, I'm running the promise, and after that I'm running the console.log hello. So if I run this, the hello will be printed first, and after that the promise will be resolved. So here the code execution happens synchronously, it goes on, and only when the promise is resolved, the console.log or this callback method will be invoked, and then this value will be printed. So depending upon the use case, what you are trying to achieve, you can use this then or the async await. Now await proves beneficial when you have to make an API call or do the asynchronous operation one after the another. So only when the previous one is done, you want to proceed to the next one, you can use the await, because only after this line is executed, you will move to the next line. On the promises case, you have to use multiple callbacks, because only when then the this then block is executed, you will invoke a function or do the next operation, and then when that operation is finished and it is invoking its then block, then you will move forward. So this is the minor difference between the async await. Now there is one another difference is, if you declare a function using async keyword, it always returns a promise. Okay, so let me undo this. Let me comment this out. So it will always return a promise. Now let's say I return the value of response over here. So you cannot directly access this here. If I console.log the value, you will see that a promise is written. See, it's returning a promise. Now, if you see, if I do the then block over here, val console.log val, then here 1000 will be printed, because the promise will be resolved. See, 1000 is printed. So even if you are declaring a function with async keyword, if you are trying to access its value, the function will return a promise and you have to use it as a promise only. So use it wisely when you are trying to declare a function. If you don't want, you don't want to access its value outside after its invocation, so you can use this, and then accordingly you can do either state updates, or you can update the variables, global variables, or invoke another function to perform the operations. But a function declared with async keyword always returns a promise. So I hope that's pretty much it. You have learned something new. Your JavaScript knowledge is revised, and I wish you all the best for your interviews. In the coming videos, I'll try to cover all the common questions for the arrays, objects, and the functions that are being asked in the interviews. So please stay tuned and don't forget to like, share, and subscribe to the channel. Thank you for your time.